Here you have to identify the graph of a function and its inverse function. So one thing to remember is when you graph a function and its inverse, the main thing to remember is the graph of the function and the inverse will be symmetrical with respect to the identity line. Identity line is y equals x, sometimes called as f of x equals x. So if you look at the first definition here, this is the identity line, y equals x. And if I have a graph of a function point a comma b, then I will have a symmetrical point b comma a if they are inverses of each other. So if it's an inverse function, it must satisfy this. Okay, and I also know the domain, which is the x value of the function. Okay, let me write function domain is equal to the range of the inverse function. And range of the function, which is the y value, is equal to the domain of the inverse function. So in other words, this will become the x value and this will become the y value. Oh, I'm sorry, the other way around. This will become the x value and this will become the y value. Okay, so with that information, let me see the first graph here. So when I see this graph, since I already have learned transformation, I can say that this is going to be a graph of f of x equals negative x squared plus 16. As such, I know the graph doesn't satisfy my horizontal line test, but because of this restriction given, x is greater than or equal to 0, it satisfies the horizontal line test. So in other words, it can have a one-to-one function. So I'm not worried about, because if I graph this without even the restriction, my graph is going to look like, let me show it to you here, negative x squared plus 16, right? So window, yes. So if you see, oh, I cannot see the complete graph, so because 16, right? I'm going to increase my y max to probably 20. We'll see if we can see the graph. You should be able to see it. Okay, so this is the graph of the functions. This is not a one-to-one function, so it cannot have as such, it cannot have an inverse function, right? But that's the reason they gave this restriction here. X is greater than or equal to 0. So they don't want anything on the negative side. So what we can do is restrict the window for x greater, put 0 there. X minimum is 0. So now look at the graph. So that's the portion of the graph which is one-to-one, which will have an inverse function. So this is how the graph should look. Now, even without the calculator, I must be able to figure this out. So I can see the first one cannot be the answer. So this one cannot be because it's facing up. Going down, it's starting from here. So this one cannot be. So this is the answer. Okay. Okay. Now the second part of the question is I need to figure out the inverse function of it. So first let me write the inverse and go from there. Okay, so first I have the function given, f of x is equal to, what did I write? I'll zoom it. F of x equals 16 minus x squared. And because of the restrictions, I know that I don't have to worry about the portion that is on the left. So I need to find the inverse function. So let me write y equals 16 minus x squared. Then I have to switch x and y, right? Again, these steps are coming from the notes, so look for it. So I'll write x equals 16 minus, this will become a y squared. Now I need to solve for y. So I'll go y squared is equal to 16 minus x. Right? And y equals square root of 16 minus x. Again, negative, I'm taking the principal square root, which is square root of 16 minus x. Now here again the domain restriction is x is less than or equal to 16, because the moment it becomes more than 16, then 16 minus it will become a negative number. Maximum I can have is 16. So there should be a restriction I have to put in here when I write these functions. Okay, so that's what is going to go here. Oh yeah, they already did it for me. See here, that's there. Square root of 16 minus x. Okay, so this now I can look at this in different ways. One way is I know I can look at the graph of this function, or I can use this function to find what is the graph that is symmetrical to the identity line for this. So first one I can say for this one there is a no, for this one there's a no, automatic no. This one is going to be an automatic no, but you know, just one quick check. So I can say this is a point when x is 0, y is 16, right? So I know on my inverse function I have to have a 16 comma 0. So that's my point, 16 comma 0. And I can pick one more point here. So this is a point when x is 2, y is 0. So I should have a 0 comma 2. So I have a 0 comma 2 here. So those are the two graphs. So this will be the answer for the inverse function. That's another way to look at this problem. Or you can take your function that you found here, inverse function, and graph this. You can take this and graph too if needed. So I can show that to you here. Like say, the next line I'll draw the identity function y equals x. To show you it's symmetrical, then I'm going to do square root of 16 minus x. Okay, that's the identity line. Hold on, let me see. Domain x is less than or equal to 16. So let's see if I can bring this at 0. Okay, so that's kind of showing me a little bit of symmetry. Little bit more clear if I can. What did I put? Yeah, I can see the symmetry. For one, I can change this to probably 19. Okay, I think it's symmetrical. So that's how we would decide this problem. Okay, this again, I'm doing a cross check for the calculator. You don't have to use the calculator. You can just look at this and graph it by picking few points and decide that which one is symmetrical.